Hello friends, welcome to all of you to Dr. Jogi's Academy. Today I will discuss about Dalton atomic theory. So basically Dalton atomic theory was given by John Dalton. Who was a John Dalton? John Dalton basically was born on September 6, 1766. He was an English chemist, physicist and meteorologist. He was best known for the development of atomic theory. His other contribution in different fields such as he worked on color blindness, which is also known as a Daltonism. He developed Dalton law of partial pressures. He discovered atomic weight of mainly six elements such as the hydrogen, oxygen, nitrogen, phosphorus, carbon, and sulfur. So Dalton atomic theory explained the behavior of matter. So this theory that is based on a two laws. One law is a law of conservation of mass, which state that mass of matter remain constant. The second law is a law of constant composition, which is also known as a law of constant proportion. In a pure compound, the atom of different elements always combine in a fixed whole number ratio. On the basis of these two laws, Dalton explained atomic theory, which is known as the Dalton atomic theory, and he made the different postulates of this theory. The first postulate of Dalton atomic theory is that each element is made up of a small particle, which is known as the atom. So each element is made up of a just one particular type of atom, which is different from the atom of other element. For instance, we have a gold element. The gold element is made up of a only same type of atom, that is a gold atoms. The second postulate of Dalton atomic theory is that the atom are indivisible. Indivisible means the atom can't be broken down further into smaller pieces. For instance, we have a small atom that is C. So it is not possible to divide this C atom into a smaller C piece, small pieces of the C element. So Dalton explained that atom they can't be divided into a smaller pieces. They are smallest particle of the element. The third postulate of Dalton atomic theory is that all atoms of pure element are identical, means they are identical in a size, mass, physical and chemical properties. The atom of one element they differ from the atom of other element. For instance, sodium atom is different from the carbon. Carbon is atom is different from the oxygen atom. Oxygen atom is different from the nitrogen atom, and no two elements have similar properties, but they may share the some physical similar physical properties such as a boiling point and melting point. The fourth postulate of this theory is the atom can neither be created nor destroyed, and this is according to the law of conservation of mass, which state that the mass of the matter remain constant during physical and chemical reaction. And this is explained by taking the example of formation of water. So as we know that water is formed from the combination of the oxygen and the two atom of the hydrogen. So in this reaction, we it is clearly shown that 16 gram of oxygen combines with the 2 gram of hydrogen atom to form 18 gram of water. So after this experiment, it clearly shows that the mass of initial reactant is equal to the mass of total product. The both are remain constant, means must remain constant, or we can say that atom can neither be created nor be destroyed. The fifth point is Dalton atomic theory is that the atom of two different elements, whenever they combine to form compound, they always combine in a fixed whole number ratio. So this is explained. This is according to the law, which is known as the law of constant composition and law of constant proportion. For instance, in a water. So as we know that water is formed from the by the combination of two atoms of hydrogen and one atom of the oxygen. And in the water, hydrogen and oxygen, they're always combined in a fixed whole number ratio, which is known as 2 raised to 1. So this clearly explains that whenever the two atoms of different element they are combined to form compound, they're always combined in a fixed whole number ratio. The sixth point is that in a chemical reaction, atom can be rearranged, combined, or separated. So this is explained by taking the example of formation of sodium chloride from sodium and chlorine. So we have a two sodium atom when combined with the chlorine to form sodium chloride. So in this reaction, it clearly shows that that is the two atom of chlorine, they get separated, and one atom of the chlorine, they are combined with other atom of the one atom of the sodium to form sodium chloride. So in this reaction, there is a rearrangement, there is a combination, or there is a separation of the atom. So next we will discuss about the main points of this theory, such as one is each element is made up of a small particle which is known as atom. The second is atom are indivisible, they can't be broken down further. Third is atom of particle element, they have a same masses, size, physical and chemical properties. Fourth one is atom can neither be created nor be destroyed during the physical or chemical change. And fifth one is atom of two or different elements. Whenever they combine to form compound, they always combine in a fixed whole number ratio. So in last one is in a chemical reaction, the atoms they can be rearranged, they are combined or separated to give the chemical reaction. So these are the main point of Dalton atomic theory. And next we will discuss about the limitation of Dalton atomic theory. So first shortcoming of this Dalton theory is that the Dalton theory doesn't discuss about the subatomic particles. However, that is according to Dalton atomic theory, the atoms they were indivisible. Indivisible means they can't be broken down further into a smaller pieces. However, the discovery of subatomic particles such as electron, proton, and neutron disprove this postulate. So, with the period of time, it clearly shows that atom is divided into a three particle, which is known as subatomic particle, such as the electron, proton, and neutron. Electron carries negative charge, proton carries positive charge, and neutron doesn't carry any charge. So, according to Dalton theory, the atoms are indivisible, but the atom can be divided into three particles. So, that is why this theory doesn't discuss about the existence of subatomic particle. The second shortcoming of Dalton atomic theory is it doesn't discuss about the isotopes. What are the isotopes? The atoms of same element having same atomic number but have different masses. For instance, hydrogen exists in three isotopes. One is the protium, second is deuterium, and third one is tritium. The both three isotopes of the hydrogen have a same atom, that is a hydrogen atom, but they have a different masses. However, the Dalton atomic theory states that the atom of same element they have same masses, but in this case, in the isotopes case, the atom of same element they have a different masses. So this is a shortcomings of Dalton atomic theory. The next one is it doesn't discuss about the isobars. Isobars means atom of different element they have same masses. However, the Dalton atomic theory states that that is the atom of different element have different masses. For instance, we have the atoms of two different elements such as argon and calcium. The both are the atom of different element, but they have a same mass, that is a 14 gram. So Dalton atomic theory that does not explain how and why the isobars exist. The another shortcomings of the Dalton atomic theory means it doesn't discuss about the allotropes. means allotrop means existence of one element in more than two forms having different properties. For instance, the carbon exists in three allotropes, such as the diamond, graphite, and fluorides. All these forms, such as diamond, graphite, and fluorine, they have one type of atom, that is a carbon. But they shows a different properties. They show the different physical property. For instance, diamond is very hard. They have a high melting and boiling point. The diamond is bad conductor of electricity. However, the graphite is very soft. It is a softest to touch. It has a low melting and boiling point, and it is a good conductor of electricity or heat. On the other hand, fluorine is very complex, bulky structure, and it has high melting and boiling point. So the Dalton they doesn't explain the existence of allotropes. And in the end of the video, I would like to special thanks to Sardar Jaspreet Singh Tripatia, Director of Gobind Sarwar School, Dr. Rishi Singh, Principal of Gobind Sarwar School, and thank you. I hope that you really enjoyed this video, and please share, comment, and like this video. Thank you.